Hello, my name is Alex Williams, and for my first video investigation, I chose the topic of the San Andreas Fault. The San Andreas Fault is a transform fault boundary. This means that there are two plates that slide against each other in opposite directions. Crust is neither produced nor destroyed at this type of plate boundary. It is also known as a strike-slip fault. The type of stress that occurs at this boundary is called shear stress. Basically, it means that the friction between the two plates as they slide against each other produces stress on the land and both plates. When it comes to the features of transform boundaries, there aren't that many, mainly because there are only horizontal features. There are no vertical features because the two plates do slide horizontally against each other. For the most part, there are linear troughs, valleys, undrained mud ponds, bays, and small lakes. The San Andreas fault line, for example, any rivers that run next to it, when they cross the fault, they will suddenly jog right because the fault line is right laterally, which means that if you were looking at someone across the fault line and the fault moved, the person across from you would move to your right. A common characteristic of transform boundaries are earthquakes. With the two plates continually moving, the places where they touch get stuck. As a result, the two plates break and scrape by each other at these spots. They produce seismic waves that travel through the ground and shake the surface. This is what we call earthquakes. The San Andreas fault line is known for two earthquakes. Yes, there are a lot of earthquakes at this fault line, but there are two well-known earthquakes. The first one was in 1857 at Fort Tejon. It had a magnitude of 7.9, and it was in Southern California near Los Angeles. The second one was in 1906, which is called the San Francisco earthquake. It is the northern part of the fault line, and it had a magnitude of 8.1. There hasn't been an earthquake in the southern part of the fault in over 300 years, which means that the next big earthquake, experts think that's where it's going to occur. When it comes to volcanoes, you don't usually see volcanoes at transform fault boundaries. Volcanoes are more common at spreading centers zones, which would be convergent boundary, and subduction zone, which is a divergent boundary. Thus, there aren't volcanoes at a transform boundary because it is neither one of those. The real-world example that I chose was the San Andreas fault line. It is located in California. It began with the East Rise, the East Pacific Rise, which was a boundary between the Farallon and the Pacific plates, when it subducted under the North American plate, about where LA is, so which is about right down here. This is about where San Andreas fault line started. As of now, it is 28 million years old, and it is 800 miles long. It is spreading northwest to southeast, and the Pacific plate consists of two plates. The Pacific plate, which is over here, moves northwest, which it would be in this direction, and the North American plate, which is over here, moves southeast. The San Andreas fault line grows about 1.5 inches per year. This is an overhead look at the San Andreas fault line, and here you can kind of see some of the linear features that I mentioned earlier. One thing I did want to mention was the San Andreas movie. Though the movie was technically about the San Andreas fault line, it was not anywhere close to what would actually happen if the San Andreas fault line was to have another major earthquake. There are two major examples, and the first one is actually depicted here, and it is the major tsunami that comes in and basically wipes out everyone. A tsunami like that, of that size, would not be, the San Andreas fault line would not be capable of producing that. for two reasons. One, tsunamis at that size are generated by earthquakes that cause major displacement in the ocean floor. And two, the San Andreas fault line is so far inward that it has nothing to do with the ocean floor, so it would not exist. It wouldn't create a tsunami that size. Actually, I don't think it even create a tsunami. The second one would be that there is a major chasm that's shown in the movie, and though there's a little bit of opening in the previous picture here, it wouldn't actually create the size of the chasm that is in the movie because the transform boundary, it rubs against each other, so it wouldn't actually pull apart that far to allow that big of a chasm in the ground. And that's it. Thanks for watching. And source it.